Today we're going to be talking about probability distributions. The probability of a single event is the number of times that event occurs divided by the number of times you observe an experiment where that event could occur. So a probability distribution is just a list of all of the possible events that can occur and their associated probabilities. So for example, imagine that you wanted to flip a coin. So if you're going to flip a coin, there's two possible outcomes. The first one is heads, and the probability of heads is 50%. The second one is tails, and the probability of tails is 50%. So the probability distribution is just 50%, 50%. Probability distributions have to follow a couple of rules. All the probabilities have to be between 0 and 1, and they all have to add up to 100%. So the probability of every event, or any event, is 100%. Okay, if we have probabilities that correspond to numbers, so our outcomes are numbers such as how much you get paid, or how much a person weighs, or how many units of a product you sell, or the weight of a planet, then we can do some more interesting things with it. So let's start with just rolling a simple die. So a six-sided die. If we roll a six-sided die, the probability distribution is going to look like this. It's going to be, the probability of 1 is going to be 1/6, the probability of 2 is going to be 1/6, etc., etc. And so we can ask about the probability of getting an even number, or the probability of getting a number greater than 3, for example. So probability distribution is just a list of all the probabilities and all the possible outcomes. I'm going to let you try one. Imagine that you had a six-sided die, and then on the side that had the 1 on it, you look at the one side of the die and you put some extra dots on there so that it looks like this. So you have a six-sided die that has no 1, but it has 2 5s. You draw the probability distribution of that. Write down the probability distribution of that. Okay, the probability distribution of that one looks like this. Probability of 2 is 1/6, probability of 3 is 1/6, probability of 4 is 1/6. The probability of 5 is 2/6 or 1/3, and the probability of 6 is 1/6. Okay, that's probability distribution. There's two different kinds of numerical outcomes you can have. You can either have a discrete or a continuous. A discrete means that it can only take certain numbers. For example, I might ask somebody how many children they have, and they can have 1, they can have 2, but they can't have 3.7 children. If you have half a child, you get arrested. Or you can ask something like a person's weight, which could be 190 pounds, could be 191, could be 191.3, 191.37461. The point is, it is continuous and it can take on a whole range of numbers. The way I like to think about this is with bread. You can either have pre-sliced bread, which is discrete, and you can only get slices that are already made, or you can have a loaf of unsliced bread, in which case it's continuous and you can slice it anywhere you want. If we have a probability distribution, we can ask questions. If we have a discrete one, we can say what's the probability of getting a certain number, 1, 7, whatever. If we have a continuous one, it gets a little trickier. But we often want to ask questions like, what's the probability of getting some range? Like, what's the probability of getting more than 7, or less than 3, or between 6.8 and 6.9? So to do that, we have to use something called a cumulative distribution function. And all a cumulative distribution function is it tells you how much of the probability has occurred to that point. So specifically, it tells you the probability of getting some number or less. So imagine the cumulative probability distribution of a six-sided die. So just a regular one, not that you've drawn on. So the probability of getting a 1 or less is 1/6. The probability of getting 2 or less is 2/6, because you can get it 1 or 2. The probability of getting 3 or less is 3/6, or 1/2. The probability of getting 4 or less is 4/6, etc. So here's what the probability distribution of the cumulative and the regular, so the probability distribution and the cumulative probability distribution, which is sometimes called the CDF. Okay, So let's go back to our slice of bread and look at it a little bit. So this is pre-sliced bread, so this is discrete. So the percentage of the bread that's in slice number 1 is 2%. The percentage of the bread in slice number 2 is 3%. In 3, it's 4%. And in 10, it's 8%. You can see all that there. So we might want to know what percentage of the bread is between 1 and 9. And you can add all those up, but if you have the cumulative distribution function, then you can immediately apply that. So let's create the cumulative distribution function. So the percentage of the bread that's in slice 1 or less is 2%. The percentage of the bread that's in slice 2 or less is 5%. So it's the 2 that's in the first slice plus the 3 that's in the second slice. The probability, the percentage of the bread that's at 3 or less is 9%. And if you go over here to 17, the probability that 17 or less, the percentage of the bread that's 17 or less is 97, 99 for 18, and 100% of the bread is in slice 19 or less. Okay, so the cumulative distribution function tells us the probability that you have some number or less. Okay, the or less is important, but the some number is also important. And the way you use that's different for discrete versus continuous. I'll show you how to use it in just a second. But what does the cumulative distribution function tell us? That's right, it tells us the probability of getting some number or less. So what's the cumulative distribution function tell us the probability or the percentage of bread in slice 12 or less is in this picture? Okay, so you see down there, 12 or less is 72%. So imagine I had dropped a pebble into the dough of this bread and I didn't know where it was after I made the bread, and you're going to go eat slices 1 through 12. Then you have a 72% chance of hitting of biting down on the little pebble I dropped in there. Now, we can also calculate the probability of getting some number or more. So say that somebody else got to the bread before you, and you're at the end and you get slices 17, 18, and 19. Okay? So what's the probability that you get the pebble if you get slices 17, 18, and 19? Okay? Or let me put it a different way. What percentage of the bread is at 17 or above? Now, the CDF calculates what? That's right, the CDF calculates some number or less. So you can't calculate the probability of 17, 18, or 19. However, remember that all the probability adds up to 100. So what we can calculate is the probability of 1, 2, 3, 4, 5, 6, 7, all the way up to 16. Okay? And if we subtract that number from 100% or from 1, then it tells us the remaining probability. Now you can see from looking at it that there's 3 plus 2 plus 1, which is 6%, is in 17, 18, and 19. If we take the CDF if we take 1 minus the CDF of 16, so 16 is 0.94, 1 minus 0.94 is 0.06. Okay? Now, here's the biggest mistake people make on this. When looking at discrete distributions, and this only counts for discrete distributions, if I say what's the probability of 17 or more, people want to put that number 17 in the formula because it's in the question. Okay? If you put the number 17, you get the wrong answer. If you put 17 in, as you can see, it would be 1 minus 97, 0.97, which would give you 3, and you can see that's clearly wrong. The way to correct this mistake is to write down what you actually want. So I want 17 or more, so that's 17, 18, 19. I can't calculate that, so I'll write down what I don't want, which is 1, 2, 3, 4, 5, 6, all the way up to 16. I can calculate that, but notice it ends at 16, not at 17. Okay? So the biggest mistake people make is putting the wrong number into the formula because they're trying to put the same number that's in the question into the formula. The way to solve that is by writing down what you actually want. What's the biggest mistake people make? Putting the wrong number in the formula. How do you solve it? By writing down what it is you actually want. So I'm going to let you do one. If I eat slices 11 through 19, what's the probability that I bite into the little piece of rock that I accidentally dropped into the bread? Okay, so the first step is to write down what it is you want. So I said I'm going to eat 11 through 19, so I write down 11, 12, 13, 14, 15, 16, 17, 18, 19, but I can't calculate that. However, I can calculate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the CDF of 10. So if I take 1 minus the CDF of 10, that gives me 1 minus 0.57, so 0.43. So 11, 12, 13, 14, 15, 16, 17, 18, and 19 have 0.43 or 43% of the bread. All right, let's do another one. And I'm going to let you struggle with this one a little bit. It shouldn't be that hard. Just think about what you need. Remember, write down what it is you want and what it is you can calculate. So imagine that I get there somewhere in the middle and I eat slices 7, 8, and 9. What's the probability that I bite into the pebble? Okay, the first step is what? That's right. Write down what it is you want. You want 7, 8, and 9. But you can't calculate 7, 8, and 9. What can you calculate? Well, you can calculate 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the CDF of 9. And you can calculate 1, 2, 3, 4, 5, 6. That's the CDF of 6. If I subtract the CDF of 6 from the CDF of 9, that gives me 7, 8, and 9. So that's 0.49 minus 0.27, which is 22%, 0.22. Okay? But the question is, if you want between 7 and 9, and so your instinct is to put 7 and 9 in the formula. But the correct things to put in the formula are 6 and 9. That's the biggest mistake people make. So if you say, why doesn't my answer match with your answer? The first thing I'm going to say is, where'd you slice your bread? And the second thing I'm going to say is, write down what it is you want and what it is you can actually calculate. A smooth loaf of unsliced bread. And you don't need to worry about where you're going to calculate it. So if I say, what's the probability of what percentage of the bread is in between 7 centimeters and 9 centimeters, you can cut it there. You don't have to worry about making sure that you figure out which slice to include and which slice to not include, because it's not sliced. PDF, the probability distribution function of a continuous variable, doesn't quite make sense because it just tells you the relative height, the relative amount of stuff that's there, but it doesn't tell you the probability of getting that answer. You have to use calculus and basically slice the bread into an infinite number of infinitely small pieces. But once you learn calculus, it's actually easy to do that. You won't have to do that because all you actually have to type in is, give me the CDF of 7. But if it's continuous and you want 7 or more, then you type in 7. You type in 1 minus CDF of 7, which is 7 or less. If it's discrete, it would type in 1 minus the CDF of 6, because you don't want to include 7 in that. It's a little bit confusing, I know. It's the biggest mistake people make, but the easy solution is simply to write down what it is that you want and what it is that you don't want. Once you write that down, it becomes a lot more obvious. Okay, so let's review. The probability of a single event is the number of times that event occurs divided by the number of times you make the observation. The probability distribution function is just a list of all the possible events or all the possible outcomes and their associated probabilities. If we have numbers that are arranged in some order, then we can also calculate the cumulative distribution function, which tells us the probability of getting some number or less. And then we can use that to calculate getting different ranges of things. So we can calculate from here to here, from here to here, from here to here, bigger, smaller, some chunk out of the middle. We can do all that with a CDF. If you just have one slice of bread and it's a discrete distribution, you can still use the CDF to calculate that. But if you're trying to pull out chunks of stuff, then you need the CDF. All right, I hope that's helpful. If you have questions, contact me. Thank you.